All right, here we have electrostatics question number 3. The coefficient of the static friction of a 40-gram cookie is 0.24. Cookie has a charge of 4 microcoulombs. How close would a hamster need to be to get the cookie to move if it had a charge of 38 nanocoulombs? All right, we have our hamster here, we have the cookie here. They both have a positive charge, so they're going to feel a force away from each other. All right, so our givens, we have a coefficient of static friction of 0.24. We have the mass of the cookie of 40 grams, but we should convert that into kilograms. So 1, 2, 3, so we have to add a 0, so 0.04 kilograms. The cookie has a charge of 4 microcoulombs, so we need to convert that into coulombs. So micro is times 10 to the negative 6, so this is 4 times 10 to the negative 6 coulombs. And the charge of the hamster is 38 nanocoulombs, or times 10 to the negative 9th coulombs. And it wants to know how close. We're looking for D again. So our equations, the electric force is going to be K Q1 Q2 over D squared. But we also have to deal with friction. So the frictional force is equal to mu times Fn. So the cookie won't move until the electric force is equal to or greater than the static electrical force. So we need to set those two equal to each other. We can solve this quickly. So on flat ground, the normal force is going to be equal to the gravitational force, which is m times g. So we can replace the normal force with mg. So our frictional force is going to be mu times m times g. So just doing the frictional force, we can do 0.25 times the mass of 0.04 times gravity, which is 9.8. So we should get a frictional force of 0.0941 newtons. All right. So now we have frictional force. If we set that the electric force equal to that force, then the cookie will start moving. So let's go ahead and isolate D in this case. We're dividing by D squared. To flip it up to the numerator, we have to multiply both sides by D squared. So we get F times D squared is equal to K Q1 Q2. To get D squared by itself, we need to divide both sides by F. So now we have D squared isolated. The top numerators are in our givens. The denominator we just solved for is the frictional force. So now we can plug in D squared is equal to 9 times 10 to the 9th. Then Q1 was 4 times 10 to the negative 6. Q2, 38 times 10 to the negative 9th, all over 0.0941. All right, we can put that into our calculator, grind it out, take the square root because we just set that equal to D squared. And we should get a distance of 0.121 meters, or that's also equal to, we can move it twice and say it's 12.1 centimeters. Either of those is acceptable. Both of them are 3 significant figures. And we're done.